Okay, welcome back. We have this short session of about 15 minutes where we are going to have announcements from our new partners. NVIDIA recently joined the OpenAirInterface Software Alliance. And before that, National Instruments, NI. Malay, are you there?
Yeah.
Yes. Okay, so let's start with the announcement from NVIDIA. Chris is the board member from the from NVIDIA at the OSA board. Chris, please.
Great, thanks, everyone. Yes, very pleased that this week that we're announcing kind of formal joining as strategic board member at the OpenAir Alliance. That's great. And there will also be some announcements or announcement this week about some joint work with the OAI and NVIDIA on a source code base station. But what I wanted to do here was set a little bit of context around where NVIDIA fits in the wireless space. As many people know NVIDIA for its presence in the gaming communities, and that's what my 16-year-old son got excited about when I joined NVIDIA some years back. Its professional line of GPUs is used in many applications spanning architecture, construction, scientific research, media, entertainment, healthcare, autonomous vehicles, and robotics. Some people are aware of the programming model for the GPUs, CUDA, Compute Unified Device Architecture, and CUDA with Ampere class and Hopper class GPUs are present in many supercomputers around the world. In more recent years, NVIDIA has taken a very prominent position in terms of AI training and AI inference, both in the cloud, in heavy on cloud infrastructure, but also in the edge, right? And there's a lot of work on hardware, but in particular on software stacks that have been developed in NVIDIA for enabling AI in autonomous vehicles and robotics. Less people are aware of NVIDIA's work in the wireless space. So I wanted to present a couple of slides on where we're currently working and what we think is important for being able to propel the cellular wireless industry beyond 5G through release 19, release 20 into the era of 6G. So one is purely software-defined RAN. So that is a key piece that NVIDIA works on. I have one brief slide in a minute on that. So no accelerators, so no bespoke accelerators constructed with FPGAs or other ASIC-style implementations. Pure C++ source code through the whole system. And core network made to down to the physical layer. Second piece, which we want to talk about today, the fundamental piece that NVIDIA does development on is in the area of software stacks for digital twins. Digital twins in many industries, for example, are used by companies such as Mercedes-Benz, Siemens, Amazon, and in recent years, we've seen the likes of Ericsson take our digital twin software stack and extend it to be able to do city scale and planetary scale simulations. In fact, 4 weeks ago, there was an announcement from a company called Heavy AI on using NVIDIA technology for a wireless digital twin. Probably no surprise that another piece of the equation that's important to NVIDIA is artificial intelligence and machine learning. And so we do a lot of that sort of work in many application spaces, including wireless. I'll kind of show one slide on that in a minute. And then finally here, Cloud RAN Next, right? The next version of cloud infrastructure. Cloud technologies at NVIDIA are important, and we continue to build hardware and software to empower that next generation of cloud. For example, again, 4 weeks ago, we announced something called the Spectrum 3750 switch, which is a telco style switch that supports telco class syncing, PPS, and all the synchronization capabilities of one would expect for wireless. And the same switch forms the compute infrastructure of the data center. So specifically, the programs we'll work on something called Aerial, which is all about a pure CUDA, or we can be C++ realization of a purely software-defined radio for 5G NR. All the signal processing is run entirely on GPUs. Florian will have some slides this afternoon that show a little bit more under the hood. I won't show them here. And we provide software development kits for researchers and developers. So we're very passionate about bringing this technology to the research community, but it's not just about research, it's also about commercial scale deployment international network operators. Digital twins with a gigantic software infrastructure called Omniverse. And Omniverse wireless digital twins could do a broad range of capabilities from system modeling, network optimization, network planning. So we saw that from Heavy AI, we've got YouTube, for Ericsson, Omniverse, NVIDIA. You see some fascinating videos from Ericsson and Heavy AI, some related to beamforming optimization, some related to network planning. Another piece that we work on is various aspects of artificial intelligence and machine learning wireless. One toolchain that we released probably in calendar Q4 last year was something called Siona. So Siona is a native ML link level simulator implemented in Python and TensorFlow. All the components in the library are differentiable, so one can compose signal processing pipelines and do back propagation through those pipelines to more easily and rapidly do experiments with introducing machine learning to the physical layer. For example, taking a receive path and replacing, say, a contraction or construction of channel estimation, channel equalization, software mapping, replacing it with a neural network and be able to do it in a very compact number of lines of code. What we announced this week together with the OAI was this end-to-end ODF platform, bringing together the worlds of OAI L2 and core network with NVIDIA Aerial L1 stack. So a platform where all source code is available at all layers in the network. Because it's Aerial stack, there's the NVIDIA layer 1. When you take a license to that, it's a source code license. So you've got a GPU inline accelerated base station capability with this combination of OAI and NVIDIA. And then finally, not to we're going to talk about it much today, but we continue to work on building new software capabilities to enable collaborative next. And there'll be more of that coming in 2023. So just one slide that shows a little bit of what this announcement is between OAI and NVIDIA. We look at the figure on the left here. This is the system that's been constructed with NVIDIA Layer 1 and OAI L2 and core network. So it's based around ORAN and 7-2x functional split. So using industry standard OIUs. IQ samples, pre-domain IQ samples are delivered over the 7-2 split interface into a NIC, so into an NVIDIA NIC, and the data flowing across this interface here deposited directly into GPU memory. So there's no host-side transfers of data from the radio units in GPU memory. So all of the green boxes here is all of the signal processing code for the physical downlink shared channels and shared uplink channels and control channels and so on. But I'll show on the signal processing side, layer 1 running on the GPU and layer 2 in the cloud from OAI. What else to say here? So it offers up multiple ways to design a system, from hosting a CUDU or CN on one server, or other factors where you might have CU and DU on one COT server, a Dell server, a Dell 750 server, or a gigabyte server, and maybe the packet core is running on a secondary server here. So off-the-shelf technology in terms of servers, GPU cards, and NIC interfaces, purely software defined for realizing performant 5G NR base stations. And then finally, it's a bit of a busy slide here, but the ingredients for the hardware piece of this are CPUs, GPUs, and SNC from NVIDIA. And then the tool change that we supply to allow people to compose systems that are built on top of the GPUs in the mix consist of layer 1 libraries NVIDIA for all the signal processing. And then currently something called CUDA virtual network function for being able to program the NICs, and then shortly moving to Docker for this. If anyone's looking carefully at the ARM slides this morning, you saw some unique chips in there called Bluefield 2 and Bluefield 3 DPUs. So Docker is the SDK that comprises of PDK and people programming language to be able to program this. So this afternoon, Florian is going to give a presentation which reveals a little more defined detail of what's under the hood, and also will be a demonstration. But we're really pleased to be part of the OAI community, and it's great so far working with OAI, Florian, and others at the OAI. Thanks, everyone.
Thanks a lot, Chris. Yes, we're very happy to have NVIDIA on board, and the work that is ongoing is pretty spectacular. We're very happy to be interfacing in this way with a third-party layer 1 for the first time. Thanks a lot, Chris.